how to fail without even trying. Well, let's start off with why should you listen to me at all, which is a great question. So you're already a smart audience. I'm a director of software engineering at Capital One. I've been working on a production serverless system for quite some amount of time now. The best thing about serverless is little spikes like that. And the best thing is not noticing those spikes until one day you're curious about, like, you know, is everything doing okay? Let me go and double check on some of these monitoring metrics. Maybe I don't have enough. So I wanted to find out who here is already using serverless. Okay, now keep your hands up if you've been using serverless for more than a month, more than 6 months, more than a year, more than 2 years. Ooh. Cool. Okay, so the system I've been running has been in a semi-state of production for about 2 years, but it's, we'll say, been in really production for maybe a year and a half. This is one of the biggest lessons to learn about serverless, that unlimited still has limitations. And the lesson here for people who are new to Lambda, right, is not to underestimate the coupling of downstream effects of unlimited scale. And I have this nice, helpful hashtag here if you want to like share this message out on Twitter. You know, let's get that trending. And so, what happened? We designed our system to break because that's the default nature of any system. So that's the biggest tip that I can give to everyone in this room is think about how your system's going to fail and just design for that. Don't just design for the happy case. And I know you're all saying, I think about the edge cases and this and that, but what happens when your database fails to connect or your database fails to return a query? And let's say you're a great engineer, so you close down and tear down your database connection, but that takes a SQL query to do sometimes. And so that can fail too with the query error or a query exception. So just remember that every single line of code that you wrote will surprise you in the ways that it can fail. Quick show of hands for people running serverless in production right now. Cool. I hope soon enough we'll get all of those hands up. How many people are thinking about serverless in production? Come on, guys. Okay, cool. So how do I scale? Well, this isn't really what this talk is about, so I just put some fun things on here. I do have a bonus slide about a canary pattern that I love, that if we have time that we'll get to. But this is normally how you scale, some examples. More importantly, how do you fail? And so this is a special audience, so I added some extra content, and I'm going to need feedback from you to know if I'm going too fast or too slow. If I'm going too fast, just look really confused, and if I'm going too slow, just, you know, look really bored, and that'll help me out. So, rule number 1 of Lambda Club. Error handling for a given event source depends on how Lambda is invoked. I wish I could take credit for that, but the real credit goes to rule number 2 of Lambda Club, which is that if you look at the list of supported event sources on the AWS documentation, every single one has this fun ending to it. How nice and friendly of them. So I think they want us to look into this and to think about that. And what's nice is sometimes it actually goes into more detail. So let's take a look at some Lambda invocations. This is a synchronous Lambda invocation. And you know, it's a fun little pun there, right? So synchronous invocations take a much bigger payload size on AWS, but they don't have retries automatically. They don't have deadletter queues. And they still get used a lot by things like API Gateway. And for those who are familiar with the AWS Lambda platform, this might surprise some people. You know, you have your nice, shiny Kinesis stream. You have a DynamoDB table that gives you a Kinesis stream for free. Well, those aren't asynchronous invocations. And they can and will fail without going into any kind of failure queue, without you noticing, unless you actually check something called an iterator age. But those are the kind of things that you get to watch for when you look at the fun AWS docs. So asynchronous invocations now, they have a much smaller payload size. Now, one of the interesting things about AWS is sometimes you can tell what service might underlyingly be providing the thing that you're using on AWS. And so this 128 KB payload size might mean that they're using something like SQS that's hidden from us or something else like that. And it gives you some fun ideas of how they're actually running it. And understanding that might help you actually understand how the systems themselves run, how they break, because sometimes it's not just enough to be like, oh yeah, I get this magic infrastructure that's just a big question mark on my architecture. It really helps to understand how things are coupled together. And again, that's what we're going to dig into here. We talked briefly about deadletter queues. Deadletter queues on AWS Lambda are a way when you have an asynchronous invocation, it will get retried, and if it fails, it will go to a failure queue. And you can look in SQS, and you can look at the queue depth, and you can see how many new messages are coming in, and all sorts of fun stuff there. You can build something to retry failures, which we built that works really well. But at another serverless conference I was at earlier this year, I asked people at the speakers dinner, do they check this metric? If you're using asynchronous Lambda invocations and you have dead letter queues, this is the most important metric that you want to have an alarm on. Because what does this tell you? It tells you that Amazon was unable to take your event payload that failed and put it into the failure queue. It's gone forever. It's deleted. You will never know what it is. And if you didn't check this graph or set an alarm for it, you would never know that that happened. And the perfect example of when this happens is IAM permissioning, right? A lot of people are having fun on cloud platforms with how do you authorize things to talk to each other, right? Your Lambda needs to be able to write events. The Lambda role needs to be able to write events to the failure queue. And those permissions could change unexpectedly, especially if you share an AWS account with other people, if you share roles and policies with other people. My advice is try to, just like your dependencies and everything else, try and have your own roles for each service that's going to run. But definitely you want to check out this metric. It's very important. Hidden coupling. So here's your fun Kinesis stream. And it's writing 100 messages per second. And here's your nice Lambda, which is unable to process 100 messages per second because it probably wants to do things with those messages, like make network calls. And so one thing that I've done here is embracing fanning out. Now, fanning out is when you take one small unit of work and you explode it into many, many pieces of work. And it's very dangerous. But you have to embrace it if you're living in the serverless world because everything in serverless is a little bit dangerous right now while it's still early. But that doesn't mean that you can't build things that are reliable and meant for scale. Now, another hidden piece of information here that we'll talk about briefly is synchronous Lambdas, such as your DynamoDB stream coming in, have a 6 megabyte payload. But you want asynchronous Lambda invocations, because you can't fan out with synchronous invocations. You need asynchronous ones. So even there, you need to be careful, because one day, your system might start getting more traffic, and there's a batch size that you set for these streams, and you may set a batch size of 1,000, but only see one message because you're low volume. Next thing you know, you start seeing 100 or 150 messages in that batch size, and you try and do this, it's going to fail because it's too big of a payload for the asynchronous invocation. And since this is synchronous, it will block all work from occurring. So keep in mind here that if you're running something with unexpected payloads, which is the point of using something like serverless, you need to fan this out, and you need to be very careful about it. Now, if you're doing something that's like a once-a-day batch job or even once-an-hour batch job, don't worry about all this stuff. Just do the synchronous, do it that way. When it starts to get too long, evaluate other things, but don't overcomplicate it too early. This is another fun pattern here in embracing fan out. Basically, you can have a DynamoDB table, and that table can start to get very, very large. And DynamoDB is interesting because if you want an index is really another table. And DynamoDB is not a nice, shiny, friendly thing always because it exposes how data is stored, right? If you query on a table in the SQL world with no index, it will do a table scan. In Dynamo, that's sort of one of the big options, right? You don't have a query that works on something without an index. You have a query and you have a scan. And so you have to do your own scanning. And so if you want to do something like check on what items in a table need to be updated or need some action taken on them, this is a fun way to go. And so what we do here is we actually have a CloudWatch event that was set to every 5 minutes. Now it's set to every 15 minutes because you have 15-minute Lambda invocations. And what it does is it quickly says, how big is the table? Those numbers lag on DynamoDB, but it gives us an approximation. We then divide that by a constant, which is, of course, an environment variable that we can tweak as needed in case something happens, because something always happens. And then we actually spin up a bunch more asynchronous Lambdas. This logic tells us, oh, okay, you have 1 million things in here. I know I can process 10,000 in an invocation based on how stale things are, right? And then it goes, okay, cool. So I'm going to divide 1 million by 10,000, and I'm going to make that many Lambdas to actually do a parallel scan of the table and then actually fan out the work that needs to happen. Very, very fun. Is everyone still with me? Cool, okay. Secret society of service limits. So this is really fun because, one, I think the graph that I made here wound up going into my appendix, so I'm going to have to pull that out. But it's even more fun because people think, oh, service limits are always numeric. Definitely not the case. There's other limits to services that you should read about before you even write a single line of code for them. And that goes with any provider and any service and any API and anything. And if some kind of API you're using or some kind of service you're using doesn't tell you what its limitations are, you're going to find them out at the worst time. And they are going to find them out at the worst time. And so it's nice when you build on something to choose something that actually tells you, hey, here's when this thing is going to break, and don't come crying to us about it because we told you way before you even wrote a single line of code about this issue. Depending on how big of a spender you are on your provider, you may have a period of time you have to wait to get these limits increased. Sometimes you have to wait just because you've decided to scale faster than other people are scaling, and you actually have to, they'll actually be like, okay, we're going to increase your service limits over the next couple of days, or over the next day it'll take us to actually scale up to that. They're not increased automatically. So plan ahead of time. And this is incredibly important if you're using an API or any kind of call to something else, which I'm going to have fun illustrating by finding where this slide went. And it disappeared, so I will just explain it. So basically, this Lambda, now just imagine over here instead, these are now your fast Lambdas that you've made. They're shiny, they're fast, they're great. And this is HTTP, hopefully HTTPS. And over here is now not a Lambda. It is some kind of a slower service or something else that might have a longer delay to scale. Like you might have some kind of computer or container group that has to scale up and down, and there's some kind of cold start to those servers as well. And you're going to get, on this side, you're going to get your 429s, you're going to get your 502s and your 503s, and all sorts of fun stuff. Not every service is going to give you a 429, but their load balancer might. Their load balancer might tell you, hey, we're unable to talk to this service. It is done. So that is actually the majority of what I had for you guys, but I wanted to share a couple more things really quick. Common issues. These are just some fun little tips that I'm throwing out there that I've seen. At Capital One, we have a serverless channel on Slack, and serverless isn't always the thing they taught you in school or the thing they taught you in a coding boot camp, and you don't always know all these underlying things, and you go, I don't have servers. I don't need to worry about things like file permissions. Well, you do have to worry about file permissions because it says in the AWS docs, Lambdas have to be world readable, and I'm going to assume they might have to be world executable. Probably not. Depends on which framework you're using, which language you're using on AWS Lambda, but the files themselves need to be done that way. As Kelsey said, you definitely need help from DevOps. Sometimes you need to be your own DevOps because you're going to run into fun issues with permissioning. Some of the frameworks out there, if you have simple use cases, are kind of wonderful about that, but make sure to actually look at those policies before you put them in production. Make sure you're namespacing things. Make sure you're saying that this service can only access its services queues and not some other services queues in your AWS account. Because guess what? Someone over there is probably just going to say, give me a list of all queues, and I'm going to start reading and deleting events off of them. You want to make sure that your services are contained within each other. That's the whole point of microservices, is this thing doesn't talk to that thing's persistence layer. It only talks to the service. And I think this is going to be the last thing. I lost my timer in there for a second. But canaries. So people talk about production canaries. Some people talk about blue-green. That's kind of like an idea that's been around for a long time. And so you might have what's called a canary release or a canary deploy, where you deploy a service and give it some percentage of the real traffic to see, is it really slow? Is it giving us a lot of failures? Is it giving us errors? Is it running out of memory? Is it doing all kinds of weird, wonky things? But a lot of times, you're not going to have that fun weather of production traffic to actually find those inconsistencies and fix them. And so I just threw together really quickly for you guys a real fun basic example of what I like to use as a canary, which is you have unpredictable scale. That's probably why you're using some kind of serverless platform. And you might not have people using your service all the day. And I've been at these startups, and I love startups. I'm a startup person, so I'm not making fun of them. But sometimes you will work at a startup that has more deploys in a day than it does visitors. And so the best thing to do there, and this is a great use case for serverless, if you just want to get started with serverless and you already have a bunch of servers, put some kind of end-to-end or integration test that actually runs against your production system, that goes through the sign-up flow like a new customer would, and actually, maybe it uses a real credit card. If that's part of your flow, your credit card company will call you eventually, and you're going to have to ask them nicely to do something about it. I know for a fact that Amex is really good about whitelisting things like that. If you say, hey, this is me, I'm testing my service, and you spend enough on your corporate Amex account, I guess they just take care of it for you. That's what happened at one of these startups. But basically, and then you can even go all the way to logging back in. It could click on a verification email. It can do all that kind of stuff. And it can also cancel the account, possibly even refund that transaction, right? So it doesn't actually hit your statement. That being said, here is this slide. If you have questions about serverless, I'm always curious what people are running into on it. So feel free to send any questions you have to me. I would love it if you just even sent a 1 to 10 score about this feedback. You can put that in the subject line. You can write notes. You can be like, I hate banana shirts. Whatever you want to say. Nothing's going to be too nice or too mean, especially not too nice. Yes?
How do you monitoring on serverless?
How are you monitoring on serverless? So we're using Datadog currently. Datadog has an interesting pattern where you print things out to standard out, or use the logging statements. Oh, it's right there. And so that's what you have to do. You either have to log out a specially formatted statement or a print for your metrics. It's going to be interesting. I know there are a lot of vendors who are working on traceability, monitoring. It seems to be a pain point for a lot of people. I would try and figure out, like if you're flying a plane, there's two kinds of ways to fly a plane. There's instruments and there's visual. I'm not a pilot, so I can't explain all the differences there. But sometimes you may run into issues with application level monitoring on serverless because of scale and other things. So make sure you feel confident with the vendor metrics, like the CloudWatch metrics that you get. They go to Datadog too, for example, but like things like your queue depth, your failure queues, all that kind of stuff. Like make sure you're comfortable flying your system blind essentially on just instruments, right? That's the good advice there. Everything can and will fail. That's the most important thing.